This is the Building Automation Monthly Podcast with Phil Zito, episode 151. Hey folks, Phil Zito here, and welcome to episode 151 of the Building Automation Monthly Podcast. And in this episode, we will be discussing how to integrate BACnet IP systems. Now, this is a topic we've talked about a fair bit in the past, and it's something that I still consistently get emails, Facebook messages, pretty much on a weekly basis now about this topic. And so let's get straight to it. If you've struggled to pull a BACnet IP system into your BAS, this episode is going to solve that problem. So we're going to go step by step through the BACnet IP integration process. This is going to be a fairly in-depth episode. I will link to some episodes that are kind of primers on the topic of BACnet. That if this episode, if you're just completely lost by the time we're about 5-10 minutes into this, then you'll want to go and listen to those episodes. Now, before we go there, this episode is brought to you by our BAS Protocol Bootcamp. So if you're struggling to understand BACnet, LAN, and Modbus, and the idea of reading thousands of pages of protocol documentation not only seems overwhelming, but you just don't even know where to begin, then we've got the answer. Our BAS Protocol Bootcamp is a fully online course that will teach you everything you need to know about building automation system protocols so that you can be successful in your BAS career. To learn more, go to buildingautomationmonthly.com/151 and scroll down to the BAS Protocols Bootcamp logo. All right, so what is this protocol integration process that I mentioned? Now, the reason I use the phrase protocol integration process instead of BACnet IP integration process is that this process will work regardless of protocols. I remember back when I worked for Johnson Controls and I was running the technical integration program, and I would work with some of the folks in the hardware and software engineering groups, and I got referred to as the API guy. Oh, that's Phil. He's the API guy. Ask him about APIs. And then, the thing is that I probably had really known about APIs for maybe a year or 2 years. And these folks had computer science degrees. So what made it that I was the API guy? Well, it was because I had a very clear process. And even though I may not have known a specific protocol, using this process, I could quickly understand what I needed to know, and I knew where to go get that information. So as you listen to this, although we'll be diving specifically into BACnet IP, this process, once learned, you can apply this to any protocol. You can apply this to MQTT. You can apply this to a JSON API. You can apply this to BACnet, to LAN, to Modbus. Whatever protocol you're working with, this will work for you. Now, the protocol integration process has really 4 steps, and those are specific to the setup, and then we'll get to the implementation. I probably shouldn't have used the word setup. I should have said the pre-work, the design work. As I've mentioned multiple times in these podcast episodes, where things seem to go wrong is where folks don't put the pre-work in. They don't have the foundational knowledge, or they just don't have a really organized process. I remember back when I was in the field and we'd be doing BACnet IP, and if you guys are like shaking your heads, I know each one of you has done this in the past if you've spent any time in the field, but it's essentially integrating through trial and error. It's where you just change settings until something works, and then you hope no one touches it so that it doesn't break. Now, that is the worst way to do integration, but we've all been there because a lot of us are never taught this underlying information, and we're not taught this process that really organizes the whole integration process. So This 4-step process is that we begin with a use case. Now, we've talked a lot about use cases in the past, and the concept of a use case can be very overwhelming for folks, but it's as simple as saying that, hey, John wants to turn on the lights through his BAS, so the use case is John's going to log into the BAS and turn on the lights. Okay, now how do we do that? Well, we do that through system architecture, and our system architecture is basically the layout of the systems that are required to achieve the use case. Now, on this system architecture, we're going to have some data flow because data is going to be flowing to and from the BAS and the lighting system. So that is what we're going to be using for this podcast. We're going to be talking about a BAS system and a lighting system. And the data is going to be flowing between those two systems, okay? And then once we've done that, we do the physical design and implementation. Now, what is implementation? Well, implementation is the process of actually implementing your integration. Now, in this case, we talked about a BACnet IP lighting system integration to a BACnet IP BAS system. Pretty straightforward. I'm going to take a sip of coffee real quick here. So hold on one second. All right. I got to have my caffeine to keep me going this morning. So, as I was saying, we are going to integrate BACnet IP, and we're going to integrate it into a BAS from a lighting system, both systems speaking BACnet IP. So the first thing we do is we define the use case. Who is the user? Well, the user is the facility operator. Okay. What system are they going to be using? Well, they're going to be using the BAS. To do what? Well, they're going to be using that BAS to command the lights. Okay, the lights are on what system? Well, they're on the lighting system. Okay, so now we've started to draft out our system architecture. Now, how's the data going to flow? This is really, really important because this is where stuff starts to get messed up. This is where folks start to not understand that BACnet IP and analog and binary values have priority arrays, and we're not writing to the right priority array, and maybe we're writing to a higher level on the priority array, meaning that it has less impact. So the higher on the priority array, the less impact. The lower on the priority array, the more impact, the more priority. So because we're writing at maybe 15, level 15 on the priority array instead of level 8, now that lighting system, as soon as it gets some sort of command from its lighting schedule, it overrides whatever the BAS is doing. And you all have been there. You all have done this. You've integrated to a Lutron system via BACnet IP, and you've had them have a schedule in their Lutron system, and it overrides whatever you're doing in the BAS. And it's a freaking nightmare to troubleshoot. Well, we avoid that by doing our data flow map. We understand where commands and responses, those are the primary things. Now, in some cases, we'll call them request response because that's technically the terminology that the BACnet protocol uses is request response. You actually have your, what's the word I'm looking for here? Give me 2 seconds. Your services. You have your services like a write property and read property, and then you have the request response from those. So your data flow map is going to look at actually, and you're going to find this at first, you're going to be like, Phil, this is so much effort. Are you seriously saying this to me, Phil, that you want me to do this level of effort when I describe what I'm about to describe? But the thing is, I want you to visualize the last time you were troubleshooting a BACnet IP integration, the last time specifically with a lighting system, how much of a nightmare it may have been. For some of you, maybe it wasn't a nightmare. That's totally cool. But for a lot of you, it probably was a freaking nightmare. And I want you to visualize that. And I want you to be honest with yourself and ask, why was it a nightmare? Why was it so hard? I mean, it should have been easy. We've been doing BACnet IP forever, but yet it was hard. Oftentimes what will happen is things fall apart kind of in this data flow map area. That's because we don't look at what points we have. We don't look at what devices we have, and we don't look at what properties and services the points we have. Because we're not looking at the services and properties, we don't know what we're writing to, and we don't know what we're reading from, and we don't know at what priority we're writing. And because of this issue right here, we will have basically opposing systems. So you'll make a command in the BAS, and then the lighting system, maybe something goes on with a schedule or a local touch panel or something, and that opposes whatever command you've made in the BAS system. And so now you've got this nightmare scenario. Plus, you've also got this concept of actual data normalization and data structuring. So let's talk about another big concept with lighting systems, which is the zone structure versus the space structure. Building automation systems are inherently a one-to-one relationship. So you'll typically have one VAV box. It may serve a couple spaces, but typically it'll serve a space or an area, and that's it. It has one zone sensor. Now with lighting systems, you have, or space sensor. With lighting systems, you have a zone architecture. And that zone architecture and data model, you may have multiple fixtures stretched across multiple spaces. Now, how do you pair that up? How do you say, well, these fixtures are in this space and these fixtures are in that space? This is where stuff becomes a little nightmarish, where you can have zones that overlap spaces and spaces that you can't really align with the appropriate zone. And so which space is going to control which zone? Because, zone 101 may be, or space 101 may be in zone 1, but space 102 is also in zone 1. Who controls the lights? Is it space 101? Or is it occupancy from space 102 that's controlling that lighting zone? And these are things that if you don't think them out, if you don't map out that data flow, then you're going to run into a lot of problems. And this is why integration still seems to be very difficult for folks, and why if you start to actually do multi-system integration and you don't use a use case and a system architecture and a data flow map, you're really setting yourself up for failure, because by not doing these things, you're actually going and pretty much ensuring that anything more than two systems is not going to work, because there is going to be a conflict there somewhere. And as soon as there's a conflict and it's not functioning, guess what? The owner's going to put everything in hand, and you might as well not have integrated in the first place. So from there, from that data flow doom and gloom map, we move on to the concept of physical design. Now, at physical design, this is where we actually physically design it. So we know, all right, this server is the BACnet IP server, and it goes into this switch, which goes into this router, and that router then goes into that switch, which goes into that lighting server. And that is the physical design. We know what ports we're going to use. We make sure that we've got our IP routing set up. We make sure that we don't have any ports blocked, both logical and physical ports. We want to make sure all of that is good. Now, we've got all of this set up. And now, and only now, is it time for us to move into implementation. I'm going to take another sip of coffee real quick. So implementation consists of 5 areas, okay? The 5 areas are going to be protocol specifics. Those are things that are unique to that protocol. Then we have data, then we have network, then we have device, and then we have connection. So what we're doing is we're essentially working through a stack. And when I say a stack, for those of you who aren't familiar, I've used the concept of stack so many times. I would hope those of you who have been listening for, for at least 20, 30 episodes would be comfortable with the word stack. But for those of you who are not, here's what a stack is. If you envision your internet connection, at the lowest level of a stack, you have your physical connection, right? And that is the physical wire and the physical signals, the electrical signals going across the wire. Then you move up a little bit and you have the data link, and this is the link between data. And then you move up from there and you have the network, and this is the network layer. And then from there you have transport, and so on and so forth. And that 7-layer stack is called the OSI model. It's something I refer to a lot in these podcast episodes, because I'm such a firm believer of where this industry is going in regards to IT and how important it is to understand that stack and understand that model, okay? So when you hear stack, you can hear it referred to as the network stack as I'm describing. Sometimes you'll hear stack, which is actually a collection of software. So it's a term that's often used in IT to define a collection of things that make up a whole system. So our implementation process has a stack consisting of protocol, data, network, device, and connection. So very similar to that OSI model, right? With the connection, the physical starting, moving to the device, moving to the network, moving to the data, and then protocol specifics. So we're going to start at the top, actually, and we're going to deal with our protocol specifics. Now, in regards to BACnet IP, there's quite a few things we need to be aware of when it comes to protocol specifics. The most common areas are what we're going to cover in this episode. We're not going to go into nuances like character sets and things like that, but we will talk about things like unique device IDs, unique network IDs, BBMDs, BDTs, etc., etc. So protocol specifics for BACnet, what we have to remember is BACnet is primarily a broadcast protocol, meaning that it utilizes who is, I am, who has, I have, for interrogating devices. And BACnet is primarily a device architecture, meaning you have a device, and under that device you have objects. So a device is an object, and a device has objects. Some common objects are analog values, binary values, analog inputs, analog outputs, and different objects have different properties. Some properties are present value, the priority array, the text, the device ID, the object ID, etc. So with our protocol specifics, we need to understand our protocols, hence why I said you all should enroll in the BAS Protocol Fundamentals course, or the BAS Protocol Bootcamp course, because it's going to teach you all of this. But with that being said, our protocol specifics around BACnet, at the top layer, we want to understand, especially because we're using BACnet IP, if we are connecting between subnets, then we need to account for our BBMD. Now, our BBMD is going to take those who is, I am messages that are broadcasts, and it is going to forward them to additional BACnet networks. Let me take a sip of water here real quick. Drink too much caffeine, now I gotta drink water. So, as I was saying, BACnet is going to take those specific broadcast messages utilizing the BACnet Broadcast Management Device and the BDT, which, if I remember correctly, stands for Broadcast Distribution Table. I always mix that up, but it's something you can Google pretty easily. And what that table does is it's a list of all the BACnet networks. And each BACnet network, which is synonymous with subnet, needs to have a BBMD with a BDT. And that BDT, that broadcast definition table, or distribution table, one of the two, it needs to have the subnet address, or the the device address of the BBMD for that specific network. That way those broadcasts can be shared. And once those broadcasts are shared, then each device on that network needs to have a unique device ID as well as a unique IP address. And that device ID and IP address will form the BACnet ID for that IP device. And then and only then can messages be sent. Broadcast messages, as I said, are sent for who is I am. Unicast messages are sent for the different services. So we want to make sure that we get all of that set up. Additionally, on top of the BBMD and BDTs that we need to get set up, and the unique device IDs and IP addresses, and the network numbers, we also need to make sure our ports are open. Typically, BACnet uses UDP port 47808 for its communication. All right. So that's a lot, right? So assuming that we did all of that correctly, now we need to understand our data. This is where we take our data flow map and we basically overlay this map against our points list. Now we want to understand the points list for the system that we are integrating to. So in the case of the lighting system, we're going to integrate to the lighting system, and it's going to have a series of points. Now, at this point, what other word can I use than point? I don't want to use point this whole podcast. At this time, we are going to go and we're going to pay particular attention to, are our points inputs or are they values? This is really important. So inputs are not going to be commandable, and they are not going to have a priority array. Values and outputs will be commandable, and they will have a priority array. Inputs and outputs are physical points, at least they should be, according to the standard. And values are logical points. Now, as I mentioned, each point is an object, and each object has properties. Some of those properties are present value, relinquish default, and our priority array. Relinquish default is where the point fails to if it has no value, and the priority array is what we command in order to set our value, at least on values and outputs. Now, these points are also going to support services, and they are going to support services for their objects, and then the devices that those point objects are part of are going to support services. So it's really important for us to understand that, because if we try to go and grab analog inputs or binary inputs, and we try to command those, which I see a lot of folks do, we will not be able to do that because they have no priority array and they don't support those services. They support the read property services, but not the write property services in most cases. Now, as I mentioned, we have to make sure our network is set up, and that is the next step. So before I leave data, so we're going to take our points list. We are going to understand what points we're mapping to. We're going to understand what priority we're mapping to. And we're going to understand what points correlate to points within the BAS. So the points on the lighting system, remember that whole space versus zone. We're going to consider that, and we're going to align our points back to the BAS system. Now, at this point, we are going to make sure that our BBMDs and BDTs are configured. We're going to make sure our network IDs, our subnets, and ports are set up according to what they need to be set up to. And then we move to our device. And it's at this point that we are going to focus in on our device ID. We're going to understand the protocol implementation conformance sheet, or PIC sheet, and its capabilities. And we're going to make sure we're not trying to do something with that device that the device is not capable of. And then finally, we're going to do our 3-step connection step, or what's the word I'm looking for? We're going to perform the 3 steps of connecting up the BAS integration. That's what I meant to say. So we're going to do wire up, network up, and open up. So wire up, we're going to connect the BAS device to the switch, just like we laid out in our network architecture. We're going to make sure the network's up and communicating, that we can ping our devices, that our tracer T is working, that our ping path is working. And then we're going to make sure everything's opened up, make sure our ports are opened up, make sure our firewalls aren't blocking anything, make sure there's no ACLs, that those are access control lists, as well as any IDS or IPS that are, and those are intrusion detection and intrusion prevention, cybersecurity tools for networks. We're going to make sure they are not blocking our traffic, and we're going to make sure all of our traffic is communicating. Another big one, since we tend to work on converged networks right now, we're also going to make sure that no one's streaming 4K video or anything across our trunk links. By the way, if you don't understand any of these IT terms I'm communicating, you definitely need to enroll in our Information Technology for BAS Professionals course, because that will give you all of the IT knowledge. It's literally a 30-hour course that will teach you everything you need to know about IT. So wire up, network up, and open up. You do these steps in order, and that, my friends, is how you integrate a BACnet IP system. I know this was very fast. I know this was very dirty. It was very much just, this is how you do it. Let's get in there and do it. But I'm telling you, if you follow that 4-step protocol integration process, that pre-work of defining your use case, your system architecture, your data flow map, and your physical design, not only does that work amazing in single one-to-one system integration. But when you get to multi-system integration, that is required. If you're not doing that, you're a fool. You're going to tank your job and things are just not going to go well. Then we go through our implementation process, the 5 steps of that stack. We're going to make sure we are aware of our protocol specifics. We're going to move through our data. We're going to make sure it aligns with our data flow map. We're going to make sure our network aligns with our system architecture and physical design. We're going to make sure our devices are set up the way they're supposed to be set up. And then we are going to follow our 3-step connection process of wire up, network up, open up. And there you have it, folks. That is how you integrate a BACnet IP system. So with that being said, thank you so much for listening to this week's episode. I look forward to talking to you next week. If you have any questions related to this topic, just go into the comments section at buildingautomationmonthly.com/151. And as I mentioned, this episode is brought to you by our BAS Protocol Bootcamp online course. I encourage you to check that course out, and you can find out more information at buildingautomationmonthly.com/151. Thanks a ton, and I'll talk to you again next week.